Pascal's triangle is fantastic for finding these binomial coefficients if it's not too high a power of x that we're going up to. Because here's the first 5 rows, counting from 0, which we're going to be doing a lot as we work through the binomial theorem work. And that's pretty fast to write down, but if I needed to get up to a much higher power, like say 13 or 26 or 112, then that would definitely not be a very efficient way to find those numbers. So we need other ways to find them. Fortunately, there is a very convenient formula that we can use to find them. So let's pull that up here. The binomial coefficient, and there is that notation that we were just using on the last slide here. So there's that in our formula. And we also have this notation that we are more familiar with from class, the NCR, N choose R. And we worked through how to find these with factorials. Just to remember, factorial is only defined for positive numbers, and when we had, say, 5 factorial, that would equal 5 times 4 times 3 times 2 times 1. So we want to make sure that we're comfortable working with our factorials in order to solve these problems. So if I want the binomial coefficient, I can use this formula. Suppose that I want the coefficients for the power of, say, 10. Well, if I'm looking at something to a power of 10, then the first coefficient, the 1, is in position 0, and that would be 10C0, and that would equal 10, that's our n, factorial, divided by, our r in this case is 0. 0 factorial is defined to equal 1, times n minus r, 10 minus r, 10 factorial. Well, 10 factorial and 10 factorial are going to cancel. They both will have the same value, whatever that is, of 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 0 factorial is equal to 1, so this is going to have a value of 1, which makes sense because the outside, the first term, the 0th term, the first term here always has a coefficient of 1. And if I want to find the next term, which again I expect to have a value of 10, because if I look at my triangle, whatever the power is, the row, the second term always has that same value. So let's check our formula here. It's going to be still 10 factorial divided by 1 factorial, which is also 1. It's just 1. And then the next part of our formula, which has hidden on us here, is n minus r. So for n minus r, that would be 10 minus 1, or 9 factorial. Well, 10 factorial equals 10 times 9 factorial. And I'm just going to leave out this 1 because 1 times 9 factorial is just 9 factorial. So these are going to divide out, and that does indeed just leave us with a 10. We can use this formula for any of them. I'm only going to do one more. For the third term here of this expansion of the power of 10, I'd have 10 factorial divided by 2 factorial, which is 2 times 1, so it just has a value of 2. 10 minus 2, that'd be 8 factorial. So I have 10 times 9 times 8 factorial all over 2 times 8 factorial. So my 8 factorials cancel. I have 10 times 9, which is 90, divided by 2 is 45. So that would be the coefficient of the next term. So as long as I understand that the first term is always the 0th term, I can just use this formula to find the coefficient of any term that I might need.